Hello everyone and welcome to our second lecture in logic. In our previous video, we talked about what logic is and why do we need logic, and we mentioned that in this course we will talk about propositional logic and first order predicate logic. And we also talked about the definition of a proposition, which is the base of propositional logic. We defined it to be a statement which can take one of the two possible values. In logic, we call these values as true and false, but in mathematics, we denote them by 1 and 0. So 1 for true and 0 for false. We will call a proposition as a propositional variable or simply a variable, because in mathematics, we are always talking about variables. In propositional logic, it should be clear that a variable can take only one of the two possible values, 1 or 0. So there were two assignment questions for you in the previous video. Let's talk about their solution. So the first statement, June 19, 2020 is Sunday. This is a propositional variable because you can evaluate it to be either true or false. But the second statement is not a proposition because I will upload a video tomorrow. Its evaluation depends upon future, so you cannot evaluate it today. So the first one is a proposition and the second one is not. And in our previous video, we also talked about 5 logical operators, which are listed here. Today, we will talk about these operators in detail. And the goal of today's video is to introduce you the concept of propositional formulas and what is meant by an assignment. It's just a function, and what are truth tables and why do we use truth tables. So these 3 concepts we will be studying in today's video. A propositional formula is just an expression. For example, in algebra, you have expressions of the form x plus y. And for instance, you do not allow expressions of the form x plus multiplied by y or x plus divided by y. So you have some statements, some expressions which are legitimate or legal expressions, and some are not. Propositional formula is a kind of way of making expressions in logic. So a formula is obtained from propositional variables using all the logical operators that we have discussed in our previous video. And in logic, we always define things inductively. So how do you form expressions from variables? So every propositional variable, we usually denote them by P, Q, R. So it's a propositional formula. And if phi is a formula, then its negation is also a formula. And if we are given 2 formulas, phi and theta, then their and, logical or, implication, and by implication, it also gives you new formulas. 2 things to notice here are that negation is a unary operator. You cannot apply negation to 2 formulas. You can apply it only to 1 formula. So it just inverts your answer. And all the other operators, logical and, or, implies, if and only if, they are binary operators. So you can apply them to 2 formulas. So this is how you form complex formulas, or in terms of algebra, the complex statements from simple variables. Now, sometimes it's very important to be clear and unambiguous. By that, I mean that you have certain statements which are legitimate formulas, but in order to evaluate them, it's very difficult because the order of operations, it might be different and it might give you different evaluations. It's simply as in numerical analysis or in number theory, the statements of the form 2 plus 3 multiplied by 7, it's ambiguous. It's difficult to evaluate these kind of statements. But in natural math, we have the rule called DMAS or DMAS rule, which says that division is always performed first, and then multiplication, and then addition, and finally subtraction. But in logic, there are no hard-coded rules. So it's always nice to have parentheses, the brackets, so that your formula is nicely readable and you know which operation to perform first. The parentheses are not always important. For example, in the case of P and Q and R, you can drop the parentheses because the truth value remains same, no matter you evaluate the first 2 variables first or the second 2. But it's not always possible. For example, in P and Q implies R, the truth value is changed when you consider the 2 subcases as given in the following line. So we have not talked about how to evaluate formulas, but the thing that I wanted to mention here was that sometimes it's important to put parentheses so that you can, so that your formula is easily readable and you know which operation to perform first. We will see in our next video perhaps that the truth value of the two formulas given at the last line, it's not same. So it depends upon how do you read a formula and where are your brackets located. Here are some example formulas. And as I mentioned, rather than writing the whole propositions, we will only write the propositional variables. So I have four statements. I'm at home, I'm bored, I'm hungry, I make food. It's just random set of statements, and I call them as P0, P1, P2, P3, and then I make formulas. For instance, the first formula says that if I am at home and I am hungry, then I make food. But now I denote them by propositional variables, and as you can see, it's more readable. And in propositional logic, we are only concerned with whether this formula in example 1, is it satisfiable? Is it always true? Is it sometimes true? Is it always false? So we are not concerned about what does P0 denote or P2 denote. In essence, it's similar to the spirit, to the idea that in a mathematics class, you begin by saying that let X denote the hypotenuse of a triangle. And then you never talk about hypotenuse, you only talk about X. So the second example says that if I'm at home, then I am bored. And if I'm not at home, then I'm not bored. So it's if and only if. And the third statement is a simply logical or. So these are the legal formulas of propositional logic. And as you can see in example 1, I have given the parentheses, but not in the other cases, because in those you can easily read the order of operations. The next definition that we will consider is that of an assignment. It's simply a function which evaluates your variables to either true or false. It's a function from set of all the variables or set of all the propositional variables, and its range is 1, 0. And intuitively, it corresponds to an observation that you have collected from your surrounding. So you are just giving your propositional values either true or false. And here is an example. So I had four propositions or four propositional variables, and by assignment, I denote it by S. It says that P0 and P1, they are both true, and P2 and P3, they are both false. When I said that this corresponds to an observation, it simply says that I'm at home and I am bored, but I'm not hungry and I do not make food. So this is specified by mapping the P2, P3 variables to 0. So this is just one assignment. And then, for example, we can evaluate the previous formulas under this assignment. Here is another assignment. We call it T. And according to this assignment, P1 and P2 variables are mapped to 1 or true, but P0 and P3 are false. So according to this observation, I am bored and I'm hungry, but I'm not at home and I do not bake food. So these are simply two assignments which map each variable to a value true or false. Sometimes we are interested in all the assignments for a collection of variables, and there comes the idea of a truth table. In this example, we have a truth table for logical OR, as you can see in the third column or the last column. And there are four assignments, and the truth table simply says that when is the case that the formula is true. And as you can see, the assignment in assignment 1, X is false, Y is false, and their logical OR is also false. But in all the other assignments, when either X is true or Y is true, or both of them are true, then the formula is true. And we use truth tables to find a satisfying assignment for a formula. So consider X or Y as our formula. Then we can see in the last column that this formula is false when both X and Y are false, as given by the first assignment. But in all the other cases, the formula is true. So when you are given a truth table, then the formula is true if the column corresponding to the formula contains 1. So now let's talk a little bit more about our logical operators. We said that they correspond to our intuition, but what does that mean? In mathematical model, how do we translate our intuitions into the values true and false? And we will talk about the truth tables and consider all the cases when is a formula involving AND operator true, and when, for example, is it false? And what about the other operators? Logical and, intuitively we know that and of two statement is true if both statements are true. And as you can see, when x and y both are false, then their and is also false as specified in the first row. And also x and y is true only when both x is true and y is true as specified in the last row. So this is only the idea how you translate your intuitions into mathematical model. It should not be difficult to remember this, but you should know that the logical AND of two variable is true only when both variables are true. Similarly for OR, as we have already seen, the OR of two variables is true, or two formulas is true if at least one of the two variables are true. And if both of them are false, then their logical OR is also false as specified in the first row. Negation is particularly simple. As we mentioned, it's a unary operator, which means that it applies only to one variable and it simply inverts the answer. So if x is false, then its negation is true. And if x is true, then its negation is false. Finally, if then or implication, it might be a bit tricky. We can think about it as saying that x is called a promise and y is called claim. So when the promise is true, but the claim is false, then your statement is false. And in all the other cases, when promise is true and claim is true, then the statement is true. And when the promise is not true, then it does not matter whether the claim is true or not. The whole statement remains true. Let's consider an example if it seems tricky. So the statement is that it is raining implies that I stay home. So we have to consider when is this statement true. First of all, the easy cases. If it's not raining, then it does not matter whether I stay home or I do not stay at home. The whole statement remains true because it's not raining. But when it's raining, then according to this statement, I must stay home in order for this statement to be true. And if it's raining and I stay home, then it's true. But if it's raining and I do not stay home, then this statement becomes false because your promise is true, but your claim is false. Perhaps the easiest case is if and only if. This simply says that x and y take similar values. So either they are both 0 or they are both 1. If you have any questions regarding the truth tables or how are these logical operators defined, you can write your question in the comment section and we will try to answer it or try to overcome your confusion. Now let's consider some examples. We mentioned that in logic, we are always concerned about whether certain formulas are true or not. Let's consider whether these formulas are true under these assignments or not. So the first formula says that P0 and P2, and we just saw that this should be true only when both P0 is true and P2 is true. In assignment S, we know that P0 is 1, P1 is 1, but P2 and P3, they are both 0. So this first formula is false because P2 is not true. We can determine whether this is true under T assignment, but we see that P0 is false again. So this formula is not true under any of these assignments. The second formula says P0 if and only if P1. And in assignment S, we see that P0 and P1, they are both 1. So yes, S satisfies this formula. And what about T? P1 is 1, but P0 is 0. So they are not equal. So T does not satisfy this formula. And finally, for the last formula, P1 or P2, we know that at least one variable should be mapped true. In assignment S, P1 is true, and in assignment T, P2 is true. So we say that both assignments S and T satisfies this formula. We will talk more about satisfaction under assignments and the symbol used for satisfaction in our next video. But here I only wanted to give an intuition of what is meant by an assignment satisfying a formula or intuitively an observation collected from your world satisfies the statements or a collection of statements. As promised, we will bring you some exercise questions, and here are two of them from this lecture. So your task is to determine whether any of the assignments S and T satisfies this formula or not. You only need to evaluate the variables first, and then using the rules for logical or negation, determine whether the whole formula is satisfied or not. So just to sum up, in today's lecture, we talked about logical formulas, which are the statements formed from propositional variables using logical connectives and following some rules, like negation is applied to unary formulas and other operations are applied over binary formulas. And we saw that sometimes it's important to put parentheses to make your formula more readable. And then we also talked about assignment functions, which are just observations giving meaning to your propositional variables. And we talked about truth tables, which are a collection of all the assignments over a set of variables. In our next video, we will talk more about truth valuation with more examples and more questions. And we will talk in detail about truth tables. So why are they useful and why sometimes they become unuseful? This all comes in our next video. So I hope today's lecture was understandable. If you have any questions, you can write in the comment section or directly email to us. The email is provided on our YouTube channel. We will be more than happy to help you. And if not, then try to solve the exercise questions to put your brain at work. And thanks for attending our course. Stay tuned and we will meet in our next video.